Good morning, everyone. This is Snigdha Sarkar, CFT Application Engineer here at KETIV Technologies, and I welcome all of you to our second Ansys Virtual Academy session. In today's session, we will be going over the basics of FEA and also introducing Ansys Mechanical. The content and demo will be presented by my colleague, Mr. John Dow, and I will be co-hosting the event. With that said, I'll let John Dow, introduce himself and take it away.
Thank you, Snigdha, for that warm welcome. And welcome to our AVA session. Thank you, attendees, for attending this AVA with us. I'm a senior applications engineer at KETIV Technologies, and I specialize in the Ansys product, specifically in the structure. A little bit of background about myself and how I got introduced to the Ansys tools. While I was attending Cal Poly Pomona for my master's degree, I needed a tool to help me understand the ballistic responses, mechanical responses of body armor. That's what I was interested in studying. And I discovered the Ansys tool, and it assisted me with my master's thesis. And I liked their tool so much that I decided to seek out a new engineering career with it, where I went to go work for the happiest place on earth, and that's at the Disneyland Resort. And at Disneyland, I used Ansys to design and validate ride coasters, transportation and service vehicles, and parade floats. And I liked the tool so much, I started to teach how to use the Ansys tools to our engineering team. And I really thoroughly enjoyed teaching other engineers how to use the Ansys tool. And I decided to move my career and started working with KETIV, where we believe in empowering today's innovators and manufacturers for a better tomorrow. Over at KETIV, we really strongly believe in sharing the knowledge that we've obtained with you. And that's what the Ansys Virtual Academy is for. That's for us to talk about the Ansys tools and what it can do for you as a designer, an engineer, an analyst, or an R&D scientist. We also are a channel partner of Autodesk, and we have webinars that go over those products and what they're capable of doing for you as well. So if you haven't subscribed to those, please do so. And I'd like to review today's agenda with you. I'd like to start today's AVA with going over a really basic overview of finite element analysis and what is it. I'd like to cover how the finite element analysis will work in the workflow for designers and engineers. And finally, we're going to be moving into a demo where I will be simulating a structural mount for a display. And you can see a preview of that over here on the bottom GIF. So a quick overview of the FEA basics. How does FEA work? Well, to uncover that, we have to visit Hooke's law, and that we'll be starting off with a spring. In the diagram you see before you, you see a spring attached on one end to a wall and a force being applied on the other end. And as I apply a force on this spring, it's going to deflect an X amount of length. If I apply twice the amount of force, it's going to deflect twice the amount, X. And that is captured in our graph on the right side of that spring, where you can see a linear relationship. And that equation is the force is equal to the spring constant times deflection. It's a linear relationship. So I formulated an equation to understand the mechanical responses of this spring. But what happens if I have a system of springs? How can I see mechanical responses in springs numbers 1, 2, and 3? There was developed a nodal method to do this. And what the nodal method is forming nodes on the end of our springs so that we can understand the deflection and the force responses in matrix form. And that's what you see on this right side over here. You see the spring on the left and the right side. If we were to understand the deflection of the springs, we would. So now we dive back into our system of springs, formulate a system of equations where we might have 4 knowns and 4 unknowns. And with this system of equations, we're going to transform it into a matrix form, where we can use computational aided engineering tools to solve quickly for our 4 unknowns. So if I knew the force that was applied, I'd understand the deflections. That's U's1, U2, U3, and U4. If I understood the deflection, I could understand the force responses in my strings. So herein the question lies. What if I had a certain geometry and applied an metric material along that geometry? Can I utilize the nodal method to understand the mechanical responses of my geometry if I apply forces to it? The answer is yes. And that is what the finite element analysis method is. It's using a mesh, which you see before you, to interact with us and give us mechanical responses when we apply loads digitally. So just imagine all these little lines here. Imagine those are our springs. So now we're going to visit Hooke's law one more time, except we're going to apply it to mechanics of materials, where we have a tensile test on the right side. And in the stress strain graph of this tensile test, you can see that there is a linear region here. This is the region in the red box where our material has not failed yet. And you could see a linear relationship here that closely resembles our springs graph on the left side and in the graph of B. With that linear relationship, we can formulate a nodal method to obtain mechanical responses. And that method looks a little something like this, where I take a cantilever beam, as an example on my left side, and I apply a mesh among that cantilever beam. And now with the nodal method, I can actually study the mechanical responses inside of this cantilever beam. So that's getting the stress responses amongst these nodes. And that math is already derived for us. Thankfully, we don't have to do it ourselves. And a little bit of more math. That's what the finite element analysis is. Taking our nodals, or the nodal method, and formulating a matrices so that we can understand and study the mechanical responses to get our stress and strains of geometries. Now, luckily for us, we have CAE tools that do all this for us. This is what's happening under the hood when you use a tool like Ansys. You're using Ansys to apply some boundary conditions and loads for us to understand the mechanical responses at any place of our geometries. And what can Ansys do for you? Well, Ansys is a powerful CAE tool suite. It has various different types of CAE tools for us. Some of them you can see on, and these are all simulations that I did myself at KETIV. And I hope to uncover these types of simulations with you in future AVAs.
Hey,
now,
JD, this is
Ansys.
Hey, JD, this is really good. I had a question. Can Ansys also do fluid structure interaction?
Yes, you guys might be aware that Snigdha did an AVA, a past AVA on computational fluid dynamics. That's another type. And what's great about Ansys is it's a very powerful multi-physics CAE tool where we can take our computational fluid dynamics. So let's just take, like, for example, the bottom left where we see an engine going through a combustion cycle. If I understood the computational fluid dynamics of the pressure of my combustion, I can apply those loads over to my structure side and study the stress. So I could get something like you see on the durability area of understanding the factors of safety and the fatigue of my connecting rods for the engine. Thanks, that's a great question. So just to answer that question really short or quickly, Ansys can do much more for you than just structures. So let's walk through the FAA workflow and how can we get started with Ansys. We first define our problem. That is, writing a free body diagram and understanding how we're going to apply our boundary conditions and our loads. Over here, you see the structural member being fixed on the left side, and on the right side, I apply a load. The next step for FEA is to perform a pre-process where we take our geometry that could come from your favorite CAD tool, and we use the meshing capabilities in Ansys to formulate our nodal method that we talked about a little bit earlier in this webinar. And as so long as I got steps 1 and 2 down, I can initiate a solve for the Ansys tool to perform all the mathematics and matrices for us in the background. And after it's done, after the solve is completed, we now have our results in post-processing, where we get to view and visualize our stress results amongst our geometry all over the volume. So over here, you can see this is a stress result. We're able to obtain stress, strain, and various other types of physics results that we're interested in. Now, with that, now that we understand the workflow of Ansys, I would like to walk into our demonstration. And we're going to start by a story. We're going to be putting ourselves in the shoes of a mechanical engineer who works for a display manufacturer that designs Visa mounts to hold these displays. Now, these displays are mounted overhead over your customer's guest. You can only imagine what would happen if your Visa mount were to fail. I wouldn't want to imagine that, because I'm going to be using the Ansys tool to study the mechanical responses in my mechanical assembly over here, the structure of my Visa mount, so I can avoid this kind of failure. And here is our problem statement. We've designed and completed our Visa mount the requirements is that for this display to support a 44-pound load. Can our Visa mount support these loads? And if not, what are the areas that it fails? So I'm going to get into the demonstration now. And to start, I'm going to be opening up the Ansys Workbench. And what you see before you is just like what the name of the program entails. It's like your personal workbench in your garage, where you have an open area for you to start working on your problems. That's this open white space area of the project schematic. Imagine on your workbench, you're going to have a toolbox. Just so happens to be on our left side here. You're going to have a toolbox full of your tools to help you solve your problems. And to start simulations, it's as easy as taking them and dropping them over into our workbench area. So we could start simulating. So I'm going to take, for example, if I wanted to do a steady state thermal analysis to understand responses of my design, I can just click steady state thermal and drag and drop it anywhere in the project schematic. And I already have a cell structure for me to start steady state thermal. If I wanted to do a multi-physics and study those thermal responses to my structural studies, I can just take and drag and drop a static structural into this project schematic area. Now I can start a new static structural, or I can actually collect the thermal responses into my static structural by simply dragging and dropping it in the cell of A6 over here. Now you see a multi-physics interaction here. And of course, this can on. I could take vibrations and drag and drop that into static structural. It's really simple here. And Ansys makes it really user-friendly. I can take random vibrations and drag and drop into my modal. And you can already see that I'm already a whole branch of different type of physics that I want to simulate. But for today's demonstration, we're going to be focusing on static structural. drag and drop static structural into my workspace. And you can see in this schematic, in this cell area, it works like a top-down workflow, just like Excel, like Microsoft Excel. You have A1, A2, and A3, all the way to A7. It's a top-down workflow. So I'm going to start in A2, where I want to define the materials that I will be using for my analysis. What is my visa mount made out of? Simple. It's static structural steel, which is a standard material that's already being applied. If I really wanted to add more materials for different type of fasteners or different type of plates or mounting hardwares, I can right click and add them here. Now I move on to the next part of my top-down workflow, which is A3, geometry. Where did I complete my design? In another CAD software, or possibly in Ansys itself, which Ansys actually has its own its own geometry manipulating tools. But I could right click and import and browse here in the geometry area, search over for our visa mount, and it's already imported. So now A3 is complete. Now we move on to A4. This is going to be the pre-processing that we were talking about, where we have to set up our analysis. And I double click on A4, and that launches Ansys Mechanical. So the nice thing about Ansys is it's CAD agnostic. It works with the most popular CAD tools. There's Autodesk Inventor, SolidWorks, Creo, CATIA, you name it. And it also works with your universal CAD software programs, such as Parasolids, STLs, and step files. So over here, you see the mechanical user interface. And on the top area is our ribbon tools. Similar to your CAD softwares, if you're familiar with them, Ansys has this ribbon tool to separate the different features for us to do our simulations. Demonstration, I'm going to be focusing on the outline area because it follows the same top-down workflow that our project schematic has. As we work from top to bottom, we're going to complete our simulation. On the right side, you can see that I can manipulate my geometry's views similar to a CAD interface. Now let's start the demonstration. In my outline is where I want to work on my top-down workflow. And I'm going to expand this geometry area and make sure that each component has static structural steel assigned to it. And as a sanity check, I have the ability to double check the material properties for structural steel here.
This is really cool, JD. This is good.
Thanks, Snigdha.
This is something that we don't get to see much on the CFD side, you know.
Yeah, it's nice to visualize all of this with like a nice user interface.
Sure.
In this material area, I can also, if I forgot to add a material, I feel free to even add different ones here. I can add aluminum and titanium very quickly. And I could also change these different components and assign them these materials I just added. Here's aluminum and here's titanium. So there's two areas that I can actually add the materials. I could do in the cell side, or I could do it directly here in Ansys. Now the next part of my analysis is the connections branch. How does my geometry interact with one another in my assembly. You can already see that Ansys has done a good job of forming these connections for me. I don't have to worry about it anymore. It's already searched through my geometry of the interfaces that are within a certain tolerance of one another. It actually formulates a connection between them. So this is similar to when you're using your CAD tools and you're doing your assembly and adding mates or different interactions. Now the next part is to formulate my mesh. And I already have an idea of the size of my mesh that I want to put in there. And as I type in the size of my mesh, I get a small trick here on my mouse. Snigdha, can you see that? I'm not sure if Zoom actually shows that. Can you see my mouse pointer?
Yes.
The crosshairs?
Yes.
Okay, excellent. Thank you very much for confirming that. I'm kind of new to Zoom.
And JD, I'm not sure if I missed this, but which Ansys version are you using? 2020 R1?
Yes, I'm using 2020 R1.
Okay, all right.
So as I click on my mesh size, I get a nice cross with a circle in it that gives me an idea of what my element size is going to be. It gives me a good approximation here. I'm going to stick with 0.05 inches for this demonstration. And to create my mesh, it's as simple as right-clicking and generating my mesh. Now I'm nearly done post-processing. I only have to apply my boundary conditions now. But so I know that I am supporting a 45-pound television, and I'll start by applying my a point mass onto the surface where the television would be mounted. And I know that that is 44 pounds. For my load, I'm going to apply standard Earth gravity. So to start my boundary conditions and loads, it's as simple as right-clicking my A5 cell, highlighting insert, and you can see all the different types of boundary conditions and loads that Ansys will apply. For my load, I'm going to be applying an acceleration on my structures member because I've already applied a mass to it. And sure gravity is pointing in the right direction, which is in the negative y direction for us with this setup. And I'm going to fix this end over here. Here's another easy method of applying boundary conditions to my geometry. I can simply just click on a surface, right-click, and insert a boundary condition. And here, I'm going to fix the end of this plate. And now we can solve. So I want to revisit that question that you asked earlier, Snigdha, about the version of Ansys I'm using.
Mm-hmm.
There might be some other attendees here that have seen the Ansys user interface. This user interface was revamped, I believe, in 2019, where it was the ribbon style was added. And something else I really like about this new revamp, they added the ability to search for my tools and my features. So if I'm lost in this user interface, if it ever becomes overwhelming for me, I can always go in the search function in the top right and search for the boundary conditions I'm trying to apply, the loads I'm trying to apply, or even if I have views.
Mm-hmm. Yeah, that's really convenient.
Yep. And if I'm ever lost and not really, and I need to try to understand what the Ansys tool behind the scenes, I can always click on any one of these settings here and hit F1 on my keyboard, and it will open up a web browser for me to understand that. Now, this is a lot of information that I won't cover in this AVA, but if I really wanted to understand more about these boundary conditions I'm applying, all I did was hit F1 on my keyboard, and it brought up a really easy tutorial manual for me to run through and to understand these.
Yep, and
I can
Ansys
see my,
has such detailed
go ahead, Cindy.
documentation, you know. I was just saying that, you know, Ansys has such detailed documentation, it can really benefit someone who's just starting off with FEA. So they'd be able to look up a lot of theory in that web browser.
Yeah. They made it really user-friendly now. So I can see my solution has been completed and it's solved. So I'm going to right-click my, and I'm going to start inserting different types of results that I'm interested in. I'm interested in the stress. I'm interested in the deflection in the Y direction, just to see how much it's going to drop after I put my load. And I want to see my factor of safety. Let's see here. And by right-clicking the solutions cell, I'm going to right-click, evaluate all my results because it's already completed its solve. And I could see the stresses in my the mechanical responses inside of my assembly here. Now there's a nice contour plot on the top left that lets me know the levels of stress in my assembly. What if I want to see the stress? I can simply just click here and take a look. Or I can actually manipulate this. If I go back to my material properties, I can see that steel yields at around 36 KSI. And what if I want to set that as my failure criteria? Well, I could double click on this contour area and type in 36 KSI. And all the areas in red are considered no good. So by using the Ansys tool, I quickly performed a stress analysis on my, and I could see that my factor of safety is below 1, meaning that I have failure. So this already tells me that we need to redesign this back, as well as a bracket that holds the television to my structure. So there's 2 areas of interest here that I'm going to have to go back and validate and redesign. So the main takeaways of this demonstration was that Ansys helps us quickly study mechanical responses of our design. It's a very user-friendly tool, and it helps designers and engineers digitally prototype their designs quickly and validate them. Without having to build your prototype, you can already start making improvements. And that concludes our demonstration.
Thank you, JD. That was a very interesting and useful demo. I think I learned a lot, especially considering that I have a CFD background. And I hope it was useful for our attendees as well. I'll be opening the floor for questions in a short while. But before I do that, I just want to remind everyone that our upcoming session will be on May 26th, same time, 10 a.m. PST. And I will be presenting the basics of geometry prep for CFD in Ansys Space Claim Direct Modeler. So please be sure to join us for that session. And also, I'd really appreciate it if you could take a minute to fill out the survey after the Q&A session. It'll really help us for improvement. With that, JD, I'll let you answer the questions that you might see in the Q&A window. I think most of them were related to the demo that you did.
Okay. Yeah, I have a lot of good questions here. I have one attendee that's asking a lot of questions about thermal structural calculations. Let me see here. Let's is it possible to vary properties with temperatures? And the answer is yes, you can do that. If I were to double click in my engineering data over here, I can see that I can start setting them on the top right according to temperature and vary them. So let me answer live, and now I'm going to go through these questions. What is the contact type used for the point mass that I applied? Reopen my model over here. So the second question is, what is the contact type used for the point mass I applied? So what Ansys does is it creates rigid points. Let me try to open this up and show you. The point mass is being applied to this face. So let me go back to this point mass. When I created this point mass, this face here, and after I create my mesh, on this face, I have all these nodes. And my point mass is applied to those nodes, as you can see here. I didn't show this earlier. I was scared that all these red lines would confuse you. All right, so I'm going to move on to our next question. So when I click on my point mass over here, you can see that I can manipulate those elements and how they interact with the face. Right now, it's deformable. I can set it to rigid. And I think going into these details, it's going to be good for another AVA session. For now, I set it to deformable. All right, so I have another attendee that's asking about the meshing capabilities of Ansys. And I understand that question because all I did was I used the auto meshing method. Ansys has really powerful capability meshing. And it's done very user-friendly. I remember when I had to take my first FEA class, my instructor actually had us model every single element individually so that we can appreciate the auto meshing capabilities that we have. So I have a user over here that's asking about how can I control my mesh here? Because all I did was auto mesh it initially. What if I wanted to take an object, one of my parts here, and I wanted to control the size? I can simply do so by filtering out a selection. I can, let me just go to geometry and I'll hide everything else. I'm going to focus on this pin here. What if I wanted to control the mesh size on this face? I could simply do so by selecting the face and applying a mesh size here directly. And Ansys will do the auto meshing for us. You can see on this face over here that the mesh is much more fine. And I could do that same setting across the entire body if I wanted. And that's a great question. I'm touching on this really lightly because I think that's a great for us to go over all of the Ansys meshing tool features over here in another AVA session. I have another question here. Can I try the software before I buy it? That's actually a great question. Can you trial the software? That's actually really good in the survey. If you guys are actually interested in trialing the software and how it can work in your workflow, please, please fill out the survey and let us know that you're interested in trying the Ansys software, and we'll connect with you. Another question here: constraints that are set in the CAD software inventor properties is Autodesk KETIV for replacing that solver. Is Autodesk KETIV looking to replace? Okay, so we have an Autodesk customer here that's asking, is Ansys going to replace the Nastran solver in the Autodesk? From my knowledge now, we support the Autodesk product and the Ansys product. So we are fully supporting the Nastran product still, and we also are supporting our the Ansys product. Okay, and then I have another question here. We're running low on time, so this probably will be the last question I get to. If I did not answer your question live, we are definitely going to connect with you and get with you to answer your questions one-on-one. Can you explain the context one more time and what are these regions? So, yeah, okay, so what you in the interactive side on the right of all these context settings, it's going to highlight to you the areas that are in contact with one another. Someone asked a question of, can we talk about the contact target body? So that for a static structural, that's not going to affect your analysis too much. Which one's the target and the contact? That's something that that's going to affect your other type of simulations for different type of solvers. But for this one, I'm not too worried about which one's the contact and which one's target. I'm going to let Ansys handle that for me in this simulation. And they did a pretty fine job of that. And I think that's actually a really good for another AVA session. Once we start diving deeper, we're going to be going over in more high level details about different settings, and we're going to have full AVA sessions on them. I think we're running low on time, Snigdha. So I think we're going to close out now on our Q&A session. I'd like to thank you all for attending. And that concludes our AVA.